What are we going to let equal u here? What would you think? 3t dv equals therefore e to the 2t. Yep. So you're going to differentiate the left-hand side, integrate the right-hand side. So let's do that now. Right, what we got for du by dt? Du by dt. 3. Yeah. Therefore, dt equals du over 3. Yeah. And over here, got to do the integral of e to the 2t half the 2t. Again, that would have a plus c in there, but we can put that in at the end. Yeah. So now you've got to plug those into the integration by parts formula and see if the integral you end up with on the right hand side is one you can integrate using the table. So we've got this integral of u dv is equal to u v minus the integral of v with respect to du. So you've got to plug those results into that formula. What you would do here is find the indefinite integral and then do the evaluation of that at the end. So let's have a go. We've got 2 theta sine theta. So if we let u equal 2 theta and dv equal sine theta. Differentiating du by d theta is 2, therefore du is equal to 2 d theta. That's that side. Yep. Integrating sine theta gives us v is equal to what's the integral of sine theta? Yep. So then we can say the integral of 2 theta cos theta is equal to, and then we want u, which is 2 theta, times v minus cos theta. I'm going to put that in brackets, minus the integral of minus cos theta du, which we want to write in that form as 2 d theta. Equal to minus 2 theta cos theta we've got a negative sign there, so 2 negative signs and a 2, so we got a minus minus 2, so it must become plus 2 times the integral of cos theta. D theta. Just taken the 2 constants out. A constant of 2 and a constant of minus 1 has come outside, and therefore change that sign. Does everybody see that? Yep. So that equals minus 2 theta cos theta plus, and then if we integrate cos theta, what do we get? That's 2 sine theta. Plus C. Hence, what we started with, the integral between pi over 2, but you calculate in radians now, and none, of 2 sine theta d theta equals brackets minus 2 theta cos theta plus 2 sine theta, close the brackets between none and pi over 2. Finish that definite integral off, a couple of minutes, evaluate that and see what final answer you get. So just for the video then, quickly, gone through the same process. Let u equal 2 theta, dv equals sine theta. Differentiate that to the u side and rearrange the du. Integrate the right hand side to dv to find v. Plug that into the differentiation by parts formula and solve. Then we deal with the definite integral, writing it out, plugging the numbers in to come up with a final answer evaluation. And then all that equals 2. Yep. Right. Next example. Start having a go at that up to the point where you plug the results of your differentiation and integration into the integration by parts formula, and then see what you think it looks like. Right? You want to do u is equal to x squared in this case. Alright? So about 5 minutes, 5-10 minutes or so to get that far. 2x, du is equal to and over here v equals the integral of sin x dx, so v is equal to so when I plug it into the formula, what do I get? Integral of x squared sin x dx is equal to x squared, which is u, like that, followed by and then that can simplify a little bit to minus x squared cos x. This constant 2 here, yeah, and that constant minus 1 there can come outside, become a plus 2 times the integral of x cos x dx. Okay, what's the problem there? X cos x dx is not in the table of standard integrals, but where have you seen it before? No, you've seen it today since quarter 3. Right near the start, we solved x cos x dx as problem 1. So what you have to do is apply parts to that again. Okay, so we'll just write down from problem 1 this is equal to, just read it out to me, the final result of the first problem we did. X sin x plus cosine x I got here when we simplified it, yeah? Therefore, integral of x squared sin x dx is equal to that bit minus x squared cos x plus 2 x sin x plus cos those brackets. Okay, and whilst, according to my friend Mr. Bird, that will simplify a bit, I'll be more than happy to take that answer in the exam anyway. Okay. So, and in actual fact, where we've got a product, a power of x there, power of x there, and that number is n, we'd have to use integration by parts n times. So if I made that x cubed, we'd end up going through that process of parts 3 times to solve. X to the power 4 times to solve. And no, I'm not going to do that because that would become far too messy and complex. Okay, but you should be aware that that's what happens. Okay. Now, just where would we start with that one? X ln x. Let u equal. Let dv equal. Okay. So what is this side differentiated? 1, and therefore u is equal to dx. All agree? And over this side, v is equal to the integral of ln x, and therefore v is equal to standard table of differentials, integrals, sorry, integral of ln x's not on there. Problem, not in this table of standard integrals. Okay, we can integrate it. I'm going to do that before we finish this afternoon, but we can't. It's not in the table of standard integrals. All right. So, new page. Let's start again. What are we going to make u equal to now? And dv. Differentiate u. So the differential of ln x's all that partial fraction stuff this morning, you ought to know that. What kind of thing do we have involving x to end up with an integral that is ln x? If we integrate 1 over x, we get ln x. So the other way, from ln, we must be 1 over x from the tables. Therefore, du is equal to dx over x. Happy? Yeah. dv. So v is the integral of x dx. The answer to that is what's the index here? 1, so we add 1 to it, divide by the new index. Therefore, the integral of x ln x dx is equal to u, what we call u, ln x times v, what do we call v, x, v, where's v? No, v is x squared over 2. ln x times x squared over 2 minus the integral of x squared over 2 times dx over x. What can you see that we can do here? That bit. That bit's going to be around ln x brackets x squared over 2. What can we do there? We do with constants. And what constant is there that you can see? Half there, isn't there? What do we do with constants? Take outside. Yeah. What else? Can you see anything else we can do there with the x's? Remember, that's x squared over 2 times dx over x. Cancel? Yeah. So that becomes x over 2 dx. Bring the x squared over 2 in front. It's probably a better place for it. ln x minus a half. What happens when we integrate x over 2? What's the index here? What? Oh, I know where he's got this from. Yeah, but we're... Yeah. I see what you're saying. That 2 was gone. Yes. So that's x to the 1, isn't it? So that becomes x squared, add 1 to the index, over 2. Let's see. Because this comes back because we add 1 to that index of 1 there. So it becomes x squared, and then we divide by the new index. We combine 2 constants here. Got a half and a half ln x, half x squared, sorry. Half times a half is a quarter. Yeah. So we could, if we wanted to, do equals x squared over 2 ln x minus a half times a plus a half is minus a quarter. x². If you got that far, you get full marks. Right, not worried particularly about the simplification at the end. You will drop marks if you don't put the constant of integration on at the finish. Okay. Now, like I said, it is possible to integrate the function ln x. How could we It's a bit tricky, I agree.